Imagine this, you are booking a flight ticket online. You hit the pay button, nothing happens. Maybe the page hangs, you panic, hit refresh, and click pay again. Suddenly, your card gets charged twice. Nightmare, right? This tiny issue could cause chaos in any system that handles payments, bookings, or critical actions. But the fix, it's actually a simple concept called idempotency, and it quietly saves systems from disaster every single day. Let's break it down. Think of a payment API. A user sends a request to transfer $100. The request reaches the server, but maybe the response gets lost before it comes back to the client. The user thinks, maybe it didn't even go through, and hits the button again. The server now sees two requests. Should it charge twice? Definitely no. That's where idempotency steps in. It simply means no matter how many times you repeat the same request, the end result stays the same. Now, here's how it actually works in practice. API solves this with something called an idempotency key. Think of it as a unique tag you attach to each request, or you can even get an ID or key from backend itself. First, backend creates a payment entity with an ID and will use the same ID as an idempotency key. And based on the state field like initiated, processing, failed, or completed, we will decide to process or not more than once. So there are many ways how we can send the idempotency key or even how we can generate the idempotency key. It can be at the client side and also on the server side. Let's stick to one way of handling idempotency in this video. When the client makes a request, say post slash API v1 payments, it generates a unique string, often a UUID, and sends it in the request header. Again, in which medium we can send, whether it's a header or a query parameter or part of a route parameter, based on the use case it can vary, but somehow we need to send a idempotency key if you are generating from the client side. Simple. On the backend, before processing the payment, the server checks an idempotency store. This could be a database table or even a Redis cache. It asks, have I seen this key before? Or even have I handled this key before? If it's new, the backend processes the payment, stores the result along with key, and returns the response. If the same key shows up again, maybe the user retried, maybe the network glitch, the backend doesn't run the logic again. Instead, it just returns the stored response from the first attempt without again processing the request. This way, transfer $100 always runs and only once, no matter how many times the client retries. Stripe, PayPal, and pretty much every serious payment API use this kind of a concept to keep things safe. Not only just payment domain, like any other domain where you see there is no room for handling duplicate requests, you need to apply idempotency. By the way, if this flow made you go, oh wow, I have seen this happen before, hit that like button. It really helps me reach more developers like you. And if you love learning backend concepts explained simply, make sure to subscribe so you don't miss the next one. So here's the takeaway. Idempotency is this tiny guardrail in APIs that most users never notice. But without it, our digital world would be full of chaos. Duplicate payments, double bookings, messed up inventories, and a lot of angry customers. Next time you click pay or book and everything just works smoothly, you'll know idempotency was silently at work in the background. Remember, sometimes the smallest concepts are the ones that holding the entire system together. Thanks for watching, and I'll see you in the next one.